Okay, in this video, I'm going to show you how to use a curve tracer to figure out a pinout on a relay. If you try to take a relay out of a board and you look up the model and stuff, you may not get a data sheet, or if you do get a data sheet but don't get the pinout, you're going to need to use this method to do it. You could use a meter, but then again, it could be, if you're not knowing the wire resistance stuff like that, it could be going off. Also, if you want to test it on a board, it doesn't tell you if that's where it is. That's the coil, but a curve tracer will. See, this is a relay right here, the one we're gonna test with. It's a 12-volt one. The thing is, I know where the contact is, the coil one, since I already tried it with it. But I'm gonna make a video. I'll show you how to go step by step with this. Right now, you see a line going left to right. That means that it's open circuit. That means no electricity can flow through your octopus tester or curve tracer. The curve tracer is not that expensive. In fact, it's real cheap. You don't need to buy an expensive one. You can just build one from scratch by using an audio cord that goes to a computer, a sound card, and a few resistors, and a transformer, a power AC step-down transformer. And that there will let you make a curve tracer. So right now we're open circuit. Now if I short circuit it, the line should go up and down instead of left to right, as you can see. And then we're back to open circuit again as I release the clips. Now I'm going to take the alligator clip and I'm going to connect it to, we're going to try all these pins here and see which ones we get. Sometimes it'll confuse you, like it did it for me, because I was going through them and there's a few pins, there's a couple pins that are like 3 pins that are shorted together. I don't know what to do in there. Perhaps it could be because that they only need to use a single pole, single throw contact out of it, and to help with the current rating of the relay, so they'll break the relay when it draws that much current. They use all the contacts for the same thing, for the same purpose. Enough about that. Let's get going. So I'm going to try this pin. Try the very bottom one. I'm gonna hook the alligator up to there. We get, hang on. Nothing. Open circuit. Then I'm gonna try next two. We get a short circuit. So that means that there we got selected those 2 pins there. One of them is normally closed and the other one is common. Now here comes the tricky part. I believe. Yeah, see? I hooked up to the next pair of pins and we got a short circuit as well. You're doing something weird with this relay. Probably best to take it off the board. But you can test this without. Most of the time your relays will test out normally, where they usually figure it out. Other times you have to apply power to it to figure out, and you got to figure out where to apply power to. You apply power to the wrong thing, you can break the power supply, make a big bang, or break the relay. There we are. There's a coil because we got an oval. The oval right there represents a coil. What did I just do now? Oh, that's just a text message. Never mind. I thought I did something. With the oval there, that's what you want to get is oval. Now let's take a look at it, see what they have for, this is an XY mode. Let's go to see what it looks like there. It looks like it's hard to tell if you do it by the dual channel. So you have to do it in XY mode. Make sure that when XY mode, make sure you set that to a little bit over 0.01, make 0.1 time persistence. See. Anyway, there you go. Now next thing is we're going to test our. I'm going to go get a power supply, and we're going to test, we're going to apply power to the pins that we just got the oval from. It should turn on. Sometimes if you leave it in circuit, leave it with a diode, this will be, I don't know, it'll have like a little thing like that on there. That, if you get that in there, that doesn't mean it's bad. That just means it's a diode in it. I didn't say anything about that either. And that's another thing that can trick you. If you use a ohm meter, you're measuring the diode. This here will tell you exactly where it is. This is why this code tracer is a very important thing to figuring out the pinout of a relay. Now let's go test it out with a power supply, a 12-volt power supply, my computer power supply. Okay, I got the computer power supply hooked up now. I'm gonna got this. I'll get a clip here on the negative, clip to a lead on this relay here, one of the bottom leads that I tested, and it come back with an oval on it. And let's see what it does. See if you hear a clicking noise. Oops, it come undone. Hang on. I got a paper clip from the other lead that goes to the positive. I got a paper clip in this here that has a green wire shorted out, so it turns the power supply on. Let's try it out. You hear that clicking noise? I'm not sure if you can hear it. Let me bring it closer without short-circuiting anything. That click noise is the relay turning on. Since it is a 12-volt relay, since it does say that in the data sheet, it turns on. However, the data sheet didn't tell us the pinout. But we were able to figure out which ones were the power ones since we did the curve tracer test with it. We went through all the pins, found the ones that made an oval shape on the oscilloscope graph on the computer. You could do this with actually a oscilloscope too if you don't want to do it on the computer. If you have one. Most likely people don't have a oscilloscope, so you can do it. So probably cheaply and best way to do it is to do it with a computer. You can do it by the computer by using audio cord. This circuit board on this Cricket wireless board, cardboard paper here is a curve tracer that I made. I had this cardboard, this Cricket wireless phone come in. I just use it for the circuit board to hold to put the copper tape on, and it seems to work pretty well. You could use the function generator, but then again, I don't know. People can use function generators to do this. Now let's see here. We're gonna get a meter now. Or maybe I'll just go back to the curve tracer since we're gonna stick with that and try to figure this out. Once you hook power to it, it will see. We should see the line going up and down, turn left to right. If we found the common and normal and closed pins on the relay. Let's do that. Okay, it's off right now, and as you can see, one of the two pins is dead short. Let's see if it does anything. Who knows? It may not do anything because it might have, this might be two commons tied together. Who knows? Because there could be something on the board, even though I cut part of it off and the rest of the components and stuff were a diode, it shouldn't make a difference, but it could have. So let's try powering power to it carefully. Oh, it is working. So that there must be normally open and normally closed, as you can see. Because as you can see, I'm applying power to it. Let's see if it does it again. Like actually apply power to it. I'm not sure if I looked up and maybe I bumped the cord and it got loose. That is from right here. Yeah, that's how you figured it out. Now we just figured out what normally closed and normally in a common is. Then other panels will switch as well too, on off. Once you figure that out. I hope this video it helped you figure out relays that are unknown for you to figure out and can help you figure out how to use them in your circuit that you want to use them. If you can't find out don't know which is a coil and whatnot, now you know how to do it with a curve tracer. Well, that's it for now. I hope you enjoyed this video. Thanks for watching. If you like it,